This meeting is being recorded.
Hello everyone. Today class is about having some experiences in logistic regression and also handling empty cells or missing values in your data set. Having said that, please download the Jupyter Notebook, also the Titanic dataset from your module. Then please log in into Databricks. As I said, for avoiding issues and avoiding too much of time fixing the connections, I'm using Databricks. From now, I don't spend time, but you already know how to go to the cluster, run a cluster, and also upload the CSV file. Also, you can either import the Jupyter notebooks that I posted for you, or type the codes or copy and paste. One of the easiest way for importing the Jupyter notebooks is you go to Home, select your ID, then next to your ID, click Import, and just drag and drop the Jupyter Notebook. After it's loaded, just click. And now you see your Jupyter Notebook. So this is about famous Titanic story. As passengers are loaded into a very famous ship, which was Titanic, and they want to cross from England to United States, but unfortunately they hit a large ice in the middle of ocean and the ship sank. So now we want to see the factors associated with the survival of people. Having said that, also as you see, I use a markdown cell here, not a cell for calculation. The way that I created, you just double click on the cell, and as you see, I put this one. And after that, it turns out to be a markdown cell. The next block is for installing a package that I use later. As you see, just pip install the package name. So you might remember when you install a package, you would see some loading and some basically some reports. For avoiding that, I can come here, click in this arrow, and select hide results. Then also let me just select my cluster. I just forgot. So Shift Enter. Now it's installing the package for me. I can click on Show Result, and I see there's too many reports there. But again, you can come here, select Hide Results to avoid those reports. Then, same as previous experiments, I'm running PiSpark, and also I need to bring a Spark session as a starting point. So Shift Enter. Then again, I'm making an app name. Later you will see more application of it, but for now we just do a practice. We create the app name, and then I import the Titanic dataset. In the previous classes, I explained how to import it. Basically, you need to identify the address on your platform. Shift enter, and now you can see a schema or the structure of the file that I just imported. So passenger ID is integer, survived integer. So passenger should be string, but that's fine for now. Passenger class, integer, name string, sex string, age numerical. You can see the dictionary here anyway, but CSP stands for sibling spouses. Numerical, parch, which is to pan children abroad in the Titanic, the number of them, so integer, ticket, string, fare, double or numerical, cabin string, and embarked, which is the port of embarkation, either any of English ports. So it seems they imported correctly. Maybe passenger ID should be changed to integer, but it should be fine. In the next block, I want to import some functions that help me do some SQL-like commands. So I'm bringing some PiSpark SQL functions. Also, I'm counting the number of cells that are known. So I said when is known, C, which C is basically iterated over data columns. So I have some columns that I'm iteration on them. Through that iteration, I'm counting number of cells when they are known. As you see, age has 177 known, and cabin 687, and embark just 2. So age is a numerical one, cabin is should be a string because it's a cabin number, but we don't count or somewhat subtract from those numbers. There's also labels. So although they're cabin number, but since they're labeled, we consider them as a categorical string, and embark should be a string too. So in such a case, when we have a numerical value, we impute with a numerical approach. It could be you predict that cells, which is not applicable, especially when your data set is too large. Median and mean are another ways of filling out those empty cells. Also, for a single one, we can impute with mode. Again, there are more advanced way of imputation, but since we are working with the big data set, at least not here is just a training, but basically we need to impute in the fastest possible way. And just keep in mind, we never impute on the dependent variable. We just impute on independent variable. Here, the dependent variable is survive, and the rest are independent variables. So if there's anything on the survived column, any null cell, we just drop. Otherwise, we impute. As I see, this is a command when you want to drop it. We either drop on the dependent variable or when more than 95% of a column is empty. Otherwise, your calculations or project prone to have bias. You might remember in last semester, we talked about Apple credit card score issue. So there is, it was Steve Wozniak and his wife applied for a credit card. They had same income, but the credit granted to Steve Wozniak, which is one of the founding father of Apple company, was much more than his wife. It might have several reasons. One potential reason that their algorithm couldn't be trained very well on the female applicants. So that it might be they don't have a good train set, which could come from dropping so many observations. So whenever you see empty cells, just don't drop all their associated observation, because it's one of the reasons that you might face bias. Unless column-wise, you also don't want to drop columns unless you have like more than 95% empty data. So from the missing node that we installed, we in MS node function, and also we convert the data table that we imported from Spark to Pandas. So we want to do some calculations related to Pandas data set using MS node function. So with the reason here, I converted to the Pandas. So let's shift enter. This function is for kind of visualization, showing that missing number. As you see, in cabin, almost you have about 20% of your data, so it's still good to impute the remaining with mode, because it's a string and bar mode, and age is a numerical one, and near 80% on full. So it's a good idea to just impute the remaining. Here, another way of looking at empty cells. As you see, you can see the distribution of emptiness. Again, it should be fine if we want to just impute them. From scikit-learn, we import imputer. As you see, sklearn, scikit-learn, and pandas are very common data sets. You don't need to install them. For some packages that are not that much applicable, we do installation with pip install. So let me just run it. So having said that, I'm picking age for imputation. As you see, the index is 0, 1, 2, 3, 4, 5. Just start from 5. So with iLock, I identify all the rows of column 5 to 6. You know, the first one is included, the last one is not included. So this is what we want to be safe in. And for imputation, first I create the imputer object by simple imputer function. Then, as you see, I'm calling fit tensor method on top of it. I'm just saying that this is the data frame columns that I want to be imputed, and they replace their location. But by the way, before that, I just made a copy of the data frame in the Python file. Now let's see what happens. So again, for showing the frequency of node, we need to convert them back to the Spark data frame. And we do same, we iterating over columns, and we count when they are not. So let's see what happens. Oh, okay, sorry, I didn't run the previous as you see, all of there's no null cell in the under A column. We still have 682, which is almost 80% of carrying for them, just to embark observations. This time I'm using something else. I'm saying that from column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and anything at 10 and after that. So these are these two columns. So I want to replace that two column and with a mode. So on top of, so I'm just saying that filling NAs with the mode of that two columns. So as you see, I'm calling mode at the last two columns, and I'm just saying that pick the first first row. The reason for that, in categorical variable, you might have more than one mode. Mode means the most frequent category, and it might happen more than one time. So for having that, we want to pick the first mode. You might have 2 or 3 modes. And also the last ILOC is just for converting to in the string to be replaced into the missing values. Again, we convert it to the Spark and see how many, by iterating through the columns, we want to see how many empty cells do we have. Let me run it again, show the result. So now we imputed all the empty cells. Let's see which columns we have again. So these are our columns. So for prediction, some of the columns may not be relevant, such as passenger ID. What's the association of passenger ID to prediction? Even the name may not be relevant. 6, age, siblings, parent and children might be. Port of, ticket number may not be relevant. Fail could be relevant because it shows the level of passenger and where they probably located. Cabin number is just a label that doesn't work. Embarked might be relevant. It's the port that they embarked. So with the select method, we just select the columns that might be relevant for our study. As you know, in machine learning, we just use numerical value for entering into models. You cannot enter in any other format. And some of the variables are not in the numerical format, like such as 6, and the port that they are embarked. So we need to convert them to the numerical equivalent. One of the ways, just using one-hot encoding, which is like creating dummy value for each category. Another one is label encoding that hopefully if later we have time, we go through that. Basically, in label encoding, you just assign numerical value for each category. You don't need to create extra dummy variables. Basically, you can try both and just report the one that has highest performance. For this one, let me import the packages. So first of all, we need to vectorize them, those variables, to be able to convert them into dummy variables. So as you see, first I use a string indexer to basically make an indexer from them, and then I use one-hot encoder to convert to them dummy variables. And same for embark. I'm call the indexer function to vectorize them and then use one-hot encoding to convert them to the dummy variables. In the assembler one, we want to format our data in the way that easier to PiSpark to analyze. Similar to the previous one, which you have a feature column and a label column. So feature column has all the independent variables, anything except for survive column, which is related to the survival of your passenger. We assign them to the feature column with vector assembler. From PiSpark machine learning classification, we import logistic regression. Let's talk about pipeline a little bit now. Later, we have more experiences. Basically, in pipeline, we identify the steps that we need to do, then call the steps to run all the functions that we want to apply for the data object. So here we just start with working with pipeline. Hopefully later we have more experiences. So as you see here, I'm making logistic regression using features as my independent variables, collection of them, and survive as a label column. Then this is my pipeline. Basically, as you see, first I make a indexer from columns, these two, then do one-hot encoding on top of them. And then here, I'm making a vector assembler for my independent variables, and at the end we do logistic regression. So it's nothing, just identifying steps that you want to do on your data. Here may not be very necessary, you can just do it separately, but again, it's a good practice for the future projects that you have pipelines. Next one, just randomly split my data in 70-30% by random split method over the data. Then in the pipeline, we fit the model over the trace. It might take a little bit. So after training our model over the train set, we can use it for predicting the train data and test data. It might bring a question for you why we use the train model for predicting the train data. We want to check if there's overfitting or not. Again, what was overfitting? So overfitting just means you train your model very well on your train data set, but you cannot generalize your model for a new data set or any test sets. So in such a case as we have, if the performance of prediction train set is way more different from test set, usually if it's much higher, it just means you did a good model for train set. It's not generalizable. So for checking if we have an overfitting, we check the performance for the train set and test sets for both of them. So with fit model, basically, we can do prediction and check the performance. Then let's do evaluation. For the evaluation, I'm bringing two packages, two functions. One of them is binary classification evaluator. This one for is AUC. Multi-class classification evaluator is for accuracy. And you can find other performance measures. And this is not the only way that you can do AUC and accuracy, but this is one of the ways that I'm doing for here. So as you see, for binary classification, we can find the AUC calling on the prediction column, and the label column is survived. And for accuracy evaluator, you need to do these three steps. First, you call empty object of multi-class classification evaluator. Then you identify your prediction column, which is prediction, and label column, which is survived. Okay, with the show method, you can show the test results, which we calculated here. So from test result, we select just these two columns. We don't need the remaining, and with show method, we can see what we predicted. Okay, these are the predictions. Some of them looks true. 0 is predicted correctly. Let me see here. As you see, 0 means didn't survive, 1 means they survived. Some of them predicted correctly, so 0 predicted as not survived, and it's some of them right, some of them are not. So let's look at the performance of our model. First, performance is AUC, or arrow under the curve. Basically, it's a good performance measure because it takes care of both classes. So here we have two classes of 0, 1, survive or not survive. Accuracy just showing the overall accuracy of your model. Either it could be very good in one group and it could be terrible in other group, but it just take care of all AUC. So let me just run it. Sorry, accuracy. Then now we can check if we have overfitting or not. First is AUC. So with AUC test, I can look at the AUC of test and the AUC of train, arrow on the curve for the train. So, and again, print/n is for just sending the pointer to the next line. So let me just run it. I see. So first AUC, one line, next AUC. As you see, there's some big differences actually. You see, about 7% differences between AUC is quite large. Let's check about accuracy. And same for accuracy, 7% differences. So what you keep in mind, it means you don't have a really good model. First of all, maybe you can improve either both accuracy and AUC. And as you see, the performance of your model in the test set is much lower than train set. What does it mean? It means you train a good model over your train set, but it's not generalizable. You cannot generalize it for a new data set. It's not a good model then. So what can you do to improve it? Basically, you can do feature selection. Sometimes if you use too many variables in the train set, it just reduces the power of your model to be generalized. So one approach is just basically doing feature selection, which hopefully we'll talk about later. And we had something similar in your previous analytics programming course. You can just jump back and pick one of those Jupyter notebooks, maybe we can use other algorithms. So here we just use logistic segregation. Maybe on top of logistic segregation, we can try other algorithms like random forest, decision trees, so on and so forth. Or tuning the algorithm. So logistic regression is a very basic one. There is no tuning option, but some other algorithms such as neural network, you can change number of hidden layers or activation function, and same for SCM. So you can play with that and improve it. So for your project, final project, I expect you guys to at least to do 3 ways of improving your performance. Even if there's no overfitting, you need to do some effort in order to improve the performance of your prediction. On top of that, here we just have train and test. Later we work with the n-fold cross-validation. So in n-fold cross-validation, we check the performance on each fold and also with the test set. So performance of each fold test set should be very similar, not too much different. And this is another way of finding if there is any overfitting or not. Okay, that's it for today. This is your first machine learning experiences in the PiSpark. Let me just go back from beginning. So first part basically is descriptive statistics and data preparation. So we take care of variable types. So here you don't need to change the schema. You might say passenger ID and also I think that one, yeah, passenger ID may not be right, but later we just drop that column. We don't never use it. Otherwise, you will remember that we had some experience on how to change a schema. So you can change the variable type. So anyway, the first step is bringing data, checking if there is any outlier. So is another step. You need to take care of outliers. Then taking care of empty cells. Also, you may do imputations. Here, we didn't have to do imputation with cabin because at the end we drop it, but just it's a practice. So for embarked, we did imputation with mode. So again, as a review, for numerical values, we do numerical imputations such as mean and median. For categorical variable, we do categorical imputation like mode. Also, we learn how to install packages in the Databricks Jupyter Notebook if it's needed. Then what was that? We did imputation here. The last part of data preparation is encoding. So again, you cannot bring categorical column into models. You need to change the data type to the numerical ones. So with the one-hot encoding is one of the approaches that you can employ to basically convert your categorical variables into associated dummy variables. Then we did logistic regression. In logistic regression, there is the easiest one. There is no need for tuning, but there's some other models you can easily do tuning. Changing some parameters. Then we start our first exercise in pipeline. In pipeline, you put the steps that you want to do for doing some of your works. So you define the pipeline, steps in the pipeline, and then apply it. And then at the end, we bring two functions from the package to do AUC and accuracy. You can do on top of that, take care of sensitivity and specific. Okay, that's it for today. Please look over this Jupyter Notebook and try to, maybe you can add some more parts into it. At the end, just keep in mind, This is a very basic Jupyter Notebook. So the way that you do in this course and maybe future, you can take the other people's Jupyter notebooks. Maybe they have some background knowledge. They are much better in terms of doing data preparation, and you do the later part for machine learning. So you can do a collaboration with the people. So at the end, you can use this basic notebook and just add more component to it to make it more fancier. So you don't need to start from scratch to everything by yourself. Here is Titanic dataset. Maybe you can understand. If you click on it, you can understand how to change the picture. And instead of Titanic, you can bring your dataset. Look at the schema. So far you can almost use all of the codes. But if the schema is not right, you can change the schema as we talked previously. Here we did imputation. Maybe here I did mode and median. So you can, instead of median, you can basically use mean. So basically you can just change some parts, add to it, and make a more complex project. So this is the approach that you need to employ to be to success in this course and even in future. So in future, when you do a real big project, you don't do everything from scratch. You use other people's notebooks, learn from them, and just add on top of them to make it suitable for your own project. So anyway, that's it. Please keep posted. I'm going to post some homeworks for you so you can do your own practice. And as a graduate student, maybe you need to search to find some documents to help you for having a more complex project. Thank you very much, and that's it for today.